So modifying from task 4A, this is the visual representation. From one goal node, I simply duplicated into many other nodes and use the for uniformity. I have decided to place the nodes on blocks with at least two adjacent walls. So usually corners like this has at least two adjacent walls. And that's where I do admit, I think these are the only places that I've missed. I missed them quite late, but um almost everything else is rather complete, and it still performs the shortest path in relative to the destination node. So what's new with the sorry, what's new with the play with the agent? The agent has a game object list, which actually it's a transform list. The agent has a transform list, which I manually assign the elements to. Can easily remove and add elements and then drag from the inspector to the index to indicate that it's part of the list and stuff. So it's still for P2, it still uses the referencing, but that's, I mean, it still references the destination node, but that's mainly for the heuristic value computation. I'm using my heuristic value is the Euclidean distance between the node to the destination node. Even without the reference, I'd still be able to do it. It's just that I'd have to perform the computation manually instead of, I don't know, rather than using the library function. So one more thing that's added, and you will see during runtime, is that the player has total path list that it will create when it's searching. It will not move until it has found the goal node and has created a path to the goal node. And the script will show how it follows the path. So it created this path from the goal node. It was able to find the goal node. It traced the best previous paths to determine to create its path towards the goal node. And then in the console, what's printing here is something for me to debug quite well. 108, this is the number of elements in the list from 0 to 107. So that is 108 elements. And that's for me to know that it's complete and nothing is wrong. But generally, it's still following the same path. And yeah. And then this is the heuristic value starting from, from goal node to the previous one. So this is the goal node, one depth, one node away from goal node, two nodes away from goal node. These are the heuristic values. Though to select the best paths, I use heuristic value plus the distance from node to node. And so yeah, generally that's it. And this is the null node before it's connected to it's the previous node of the initial starting point node. And generally that's it. So we can trace it a little. It's quite hard since I am not familiar with Unity tools. But if you want to go here to the start area transform is the first one. Transform 5 and then 14 to 19. Okay, let's do 14 to 15 and then Peter, so it's fair. 1, 2, 3, 4. Transform 105, 14, 15. Area 105. So this is the area. Yeah, I'm guessing this is 105. And then 14. 15, 14. 15, 16. Is that correct? 105, 15, 16. 105, 14, 15, 16. That's 14. Oh, there's a node here that's connected to it. Can't pass here yet. 14, 15, 16. And then towards the end is 97, 96, 95, 94. Yeah, that's the very bad example since they're not connected to anything. But generally, this is where they are. 7, 96, 95, 94. 97, 96, 95, 94. So it should connect to from 94 to 75 and not 76. So from, yeah, 94 to 75. And generally that is it.